Hello, here's an exercise on variance suitable for years 16 and above. It doesn't require any special techniques apart from basic integration and familiarity with the definitions and properties of expectation and variance. So the problem here is that we're given x and y to be continuous random variables, independent, and with probability density function x to the minus half minus 1 when x is between 0 and 1 and 0 otherwise. And we've got to find the variance of a third variable z, where z is equal to twice x minus 4y plus 2. So first of all, we need to find the expectation of x, which is the same as the expectation of y, and that's the integral between 0 and 1 of x times the probability density function, x to the minus half minus 1 dx, which simplifies to the integral of x to the minus half minus x dx, and that's quite easily carried out. So that's 2/3 x to the 3 upon 2 minus x squared over 2, evaluated between the limits 1 and 0, which is 2/3 minus half, which is 1 over 6. And then we find the expectation of x squared, which is the integral of the probability density function, x to the minus half minus 1 multiplied by x squared. And that will then be x to the 3 upon 2 minus x squared, the integral of, which is 2/5 x to the 5 upon 2 minus x cubed over 3, evaluated between the limits 1 and 0, which is 2/5 minus 1/3, which is 1 over 15. Now, by definition, the variation of x, or for that matter, the variation of y, is the expectation squared, the expectation of x squared minus the expectation of x all squared, which is minus 1 upon 15 minus 1 over 6 squared, which is 1 over 36. So that's 12 minus 5 over 180, which is 7 over 180. And then finally, the variation of z will be 2 squared times the variation of x plus 4 squared times the variation of y plus the variation of 2, which is 20 times 7 over 80 plus 0, which is 7 over 9. And that does us. And thanks very much. Just one thing, I think I said variation, I meant variance. Apologies for that. Thanks very much again for listening.